In this video we will talk about the number one C++ mistake everyone does, and it has to do with premature optimizations. I guarantee that you take wrong decisions when optimizing your code, and I'm going to use this video to prove it. And I also have a little quiz for you. 5 questions, and you get a point for each correct answer. So we can see how much you struggle with this mistake. Or maybe you never make it at all. Don't worry if you don't get all answers correct. I see this mistake literally non-stop, and almost no one talks about it. Also, I explained the difference between performance and efficiency. They are not the same thing, and people focus on completely the wrong one. And I have a super weird example, later, so I can prove to you that micro-optimizations are not as simple as you think. So I need you to see it. If you want to actually evolve in your C++ journey and not be like the others, please watch the whole video. Enjoy! I prepared an analogy for you that will make things clear. Imagine it's 2012, and you and your friend Jeffrey are playing the best game ever known to mankind, Good Game Empire. You are both in a super weird situation though. You both have plenty of forests, and so much wood, you don't even have where to store it. But you are lacking on stone quite a lot on the other hand. What would you do in this situation? This is the first question of the quiz. And I think most people would focus their efforts in getting more stone. Maybe even selling the extra wood at a bad price, or reassigning the woodcutters to the mines. It's normal after all. You have extra wood, so don't focus your efforts there, but focus it where you are lacking. So you get your first point if you'd also do this. But let's look at what Jeffrey is doing. Jeffrey built a lumber station, and he's very proud of it. It increased the wood production by 50%, and that's a lot. This is the second question. Do you think building this lumber station is a good thing? I mean, 50% is a lot, and maybe we will need more wood in the future. But it's not a good idea to build this now. And you get a point if you also said this. Let's see why. 50% is a lot for sure, but right now it won't help us. We already have more wood than we can carry. Here is where people get things wrong. Maybe we don't need this now, but it doesn't hurt to build it anyway, right? Well, it actually does. You see, nothing in this world is free. In the best case, you pay at least with your valuable time. To make this building, Jeffrey had to spend time working on it, instead of making another stone mine. And worst of all, Jeffrey had to spend stone to make this. Once you see this whole picture, you realize how dumb this is. Instead of focusing on the thing that actually matters, Jeffrey focused his time and resources making more useless wood. Yes, there is a 50% chance he might need wood in the future, but there is a 100% chance he needs stone now, and a 100% chance he doesn't need wood now. So, how does this apply to coding? I have a super interesting example from my Discord server. This guy started making a Minecraft clone, and he made an optimization to heavily compress the chunks, from hundreds of megabytes to only a few megabytes. That's quite an insane optimization. But is it a good thing or a bad thing? Well, it actually depends. Similarly to the lumber mill building example, let's think for a second about this optimization. So, we save on a ton of memory, but memory is quite an abundant resource usually. Like, you don't want to spend 10 gigabytes in your game for sure, but half a gigabyte is basically nothing. For context, my Minecraft clone doesn't have any memory optimizations at all, and it still consumes way less RAM than Minecraft, just because it's made in C++ and not Java. Moreover, this optimization might have drawbacks. Storing the chunks in a compressed format might cause a performance problem, because it takes longer to read blocks from the world. Also, it might make it harder to add blocks with extra data. Finally, once you add many block types, the compression might not work so well in it. So if you ask me, if I were to pick between less RAM spent or a performance improvement plus easier code structure, I would pick this option. Since we have plenty of RAM, performance and code structure are more important. But we are not done with this example. You may notice I said this optimization might cause a performance problem. Well, that's because you can't know this yet. People oversimplify optimizations, but in reality they are extremely complex. You might think that having smaller chunks means less cache problems, but not necessarily. And after spending like 2 minutes explaining why not, I realized there might be a case where it might be beneficial. So think about this for a second. I've been coding exclusively in C++ for over 10 years. I made not one, but 3 Minecraft clones, spending like 4 years on the last one. And with all the experience that I have, I can't tell you for sure if this will hurt performance or improve it. Most people like to think about cache and things and determine if something will run faster, but in reality, you have to lower down your ego. The only way you can tell if something will be faster is to measure it. So we will know if this thing hurts performance only once the game is in a more mature state, like with more features, and we can measure the two. People think that they should just add as many optimizations as possible, but just like in the lumber mill building example, they optimize for things that they have plenty of, and they then pay hidden drawbacks. In this Minecraft chunks example, the memory optimization is real, but I'm not sure if it is that important right now. As for performance, we can't know that yet. What we can know is that this will make the code a little more complex. Now, of course, this is only a super small system. But if all your systems are just premature optimizations, you will pay by making your program more complex for no reason. What you should do is keep your code super simple, with almost no complex optimizations. The only optimizations you should do are normal basic things that you are sure don't hurt your code, like reserving a vector or taking a big object by reference. Focus instead on making the code simple and hard to fail. Don't assume your code will need more optimizations, it won't. This isn't Python. In Python, you literally can't iterate over a texture because it would take too much. In C++, you can do for loop go brr and be done. And I don't want to see you spamming the comment section, saying that I promote badly optimized code. Optimizations are not done randomly. You don't just randomly decide the system is slow and you randomly add some things that you think will optimize it. You are literally hurting your code, and you don't even know if you have a benefit. You optimize only when you know for sure you need that. Like for example, if your game starts to lag, and you don't do it blindly. Measure what system is taking too long, then measure how long it takes. Then do the optimization, and measure again. See if the new measurement actually improves the speed. Now, I know you don't believe me, so I'm gonna prove you don't know anything about optimizations with a super weird example. And then, I will explain what is the difference between performance and efficiency. So a lot of people like to pass things by const reference. But what about small things? Like I have a super small struct. Does it matter if I pass it as a const ref or by value? This is the third question of the video. And the correct answer is that it doesn't matter. So you get a point if you said that. Well, the difference between copying like 4 floats and reading them from a pointer is like so small, you can barely measure it. It's like the program is an entire ocean, and you drop a single drop of water with this optimization. Yes, sure, don't copy a super big struct, but you should not care about micro optimizations. And here is the thing, who told you that copying memory is slow? In reality, because this struct is small, it's going to be copied into registers in this case, and be super fast to access, whereas this pointer will need to be read from RAM, and this is much slower. But in reality, 99% of the time, the compiler will actually optimize it away. Both of these implementations will perform exactly the same, as you can see here. But wait, because I have another example, where I again take something by value, and then my reference. And in this case, the function that takes it by value is significantly faster. What? I'm going to explain you why, but you have to promise me something, okay? You have to subscribe. I'm just kidding. You have to promise that you will stop pretending to be a micro-optimization expert, okay? Don't go telling people that, actually, here you need to pass this by value because cache lines. No. This example proves that micro-optimizations are not easy, and that if you ever want to do things like this, you need to measure and read assembly. Just keep your code simple, and don't even think about small things like this. Now, this weird example happens because of something called pointer aliasing. Basically, we have 2 pointers here, and the compiler can't prove that the second pointer doesn't ever modify the first pointer data, even though the first one is const, so it can save its data in registers. It has to reload it from memory every time, in case it was modified from the second pointer. Const doesn't actually mean constant, it actually means that it can be modified from here, but it could potentially be modified from somewhere else. Let me give you another example. I said in a recent video to always initialize your variables, and also to always declare them where you actually need them. Now, people commented on examples like this, that because this is a for loop, we don't want to create a variable every time and initialize it, so they say it's better to do this. So question 4, does the performance difference matter in this case? Well, the correct answer is no, of course not. Like, the entire program is so big, do you really think something like this will have any impact? And as it was with the last example, the compiler is more complex than you think. There is no such thing as creating an int. This will just be stored in a register, so it's not like the compiler will have to recreate it inside the for loop every time. Also in this case, initializing the variable to 0 inside the for loop is literally a free instruction. Like, I'm not talking a 0.0001% difference, I'm talking literally free. Because of how the CPU is built, storing 0 in a register is something that can be done as an extra instruction, for free, without wasting any CPU cycles. The takeaway from this is not that this will always be a free instruction, but it is that you can simply assume that this will cost performance. So focus on real things, like making your code less error prone and easier to expand. Finally, let me tell you what the difference between performance and efficiency is, because they are not the same thing. Performance is how fast something is. So you can say that a game running at 120 FPS is performant, but efficiency is how well your program uses the resources, or in other words, how many things it doesn't waste. Think of the bubble sort algorithm. It's quite an inefficient algorithm, especially compared to quicksort, and you might say it's also less performant than quicksort, but that depends, because if you have few elements to sort, like let's say only 10 elements, quicksort will still be faster probably, but in the end, they will both be super fast. And I tested this, and the difference is super small. So in that case, both are actually performant, while bubble sort is terribly inefficient. Sure, bubble sort is an n-squared algorithm, but with 10 elements, you get to like 100 comparisons. That's literally nothing for a computer. And it is the performance that you should care about, not the efficiency. Sure, most of the code that you will write will be terribly inefficient, but no one cares about that. So the last question is, do you usually try to squeeze every last bit of efficiency out of your code? Like for example, do you usually try to squeeze your data in as little space as possible? Or do you try to write weird mathematical formulas because they might be faster? These things are not bad if used in the right place. But if your whole program is like this, you are just hurting your code quality for a probably 0% performance increase. So you get the last point. If your code is not full of things like this, it only matters how fast your program will actually run. And trust me, it will run super fast. This is my Minecraft clone, running in debug mode, and it only lags when it has to load chunks. Your code won't get slow, trust me. And when it does, you just have to measure it and optimize the small portion that needs optimization. Don't focus on improving performance when you don't need to. Focus on keeping your code simple, correct, and hard to break, because code quality degrades much faster than performance. And for that, watch this video to see some good coding practices that you can do. See you there.